Okay, so I'd like to show you a couple different ways that you can determine the approximate heart rates here. One that's not the greatest, but will work. The other one is very accurate, actually, and is closer to the way that the computer will determine the heart rates. So the first one here, if you remember, we had our paper moves by at 25 millimeters per second. Paper moves at 25 millimeters per second, and there's 5 millimeters or 5 small blocks per large block. So if you take the 25 divided by 5, that's 5 large blocks that go by per second. We kind of walked through this once before, but it's good to review. And then if you went through that for 6 seconds, 5 large blocks per second times 6 would be 30 large blocks went by. Well, that's a tenth of a minute, so again, if you go 5 large blocks per second go by, and there's 60 seconds in a minute, then a 60-second strip would have 300 large blocks that go by during that time. So I'm going to start out our chart by drawing 300 up here in the corner. Now if I take that and we were to look at a heart rhythm, and let's say that the heart rhythm is regular, because for this technique, it really needs to be a consistent heart rate. The beats need to be the same distance apart, otherwise this doesn't work quite as well. I'll show you a couple workarounds on that, but that's why this 6-second rule applies to most of the rhythms you're going to deal with and works just fine for our purposes. So if I take this 300 large blocks that go by every minute, and there was a QRS, there was a heartbeat that occurred on each and every one of those. These beats were really crammed close together, because you've seen what the graph paper looks like now, and that would be a really fast heart rhythm. If 300 boxes went by per minute, and there was a beat on each one, well, quite logically then, we'd have a total of 300 beats per minute. Now, if it was every other beat that we had a heartbeat show up on there, every other large block. So I have the first QRS shows on the first large block, then there's an empty one, and then there's a beat on the next block. It would be every other, so half as much. It would be 150 beats per minute. Now, be careful here, it's not cutting it in half again. If I go to every third block, well, every third block would be 300 divided by 3, so the number of large blocks that's between the QRSs, and that would give me a rate of 100. 300 divided by 3 is 100. Now I'm going to just go ahead and fill this in a little bit quicker, and you can kind of go back and review it if you'd like, but every fourth block would be 75, every fifth block would be 60, every sixth block would be 50, and every seventh block would be about 42.85 or so. I'm just going to round that to 43. Now, while this is quite a range, I mean this range here between 150 and 300 beats per minute, there's a huge difference between 150 beats per minute and 300 beats per minute. But the good news is that if you remember, the normal heart rate for a resting adult is from, oops, and I did that wrong. Let me mark that out in the wrong spot. So is from 60, so let me do it from the right side here, from 60 to 100. And this one is going to be a normal sinus rhythm. If it meets all the characteristics of sinus, has a heart rate between 60 and 100, that's what we expect. That's a normal heart rate. That's a normal sinus rhythm. If I come up here and it's between 100 and 150, this is sinus tach. And you're going to learn this one here in class next time, atrial tach. Atrial tachycardia is if the heart rate's up over 150. And if it's less than a rate of 60, but we met all those other characteristics, we'd have sinus bradycardia. So even with this coarse reading, you're not very accurate with the heart rate, it works. Now, that being said, I do want to show you, because you should be familiar with the other methods, but the primary way you're going to be doing everything for this heart reading, EKG reading in class, just use the 6-second strip method. That works great. If I give you a couple of beats, I might ask you what's the approximate heart rate of these two beats and try to get you to use another method to determine the heart rate. But this works if the heart rate is regular. Now, while this is not very accurate, we can be much more accurate if I did this, how many small blocks went by per minute. So if I have a heart rate of 1500 beats, or I'm sorry, 300 large blocks go by every minute. Well, there's 5 small blocks per large block, so we have 1500 small blocks go by every minute. Well, now, logically, if it was every small block, it would be a ridiculously fast heart rate. This would not be consistent with human life. So a heart rate of 1500 just isn't going to cut it. But if it came out, and logically you can do some of these easy math numbers in here, if it was every 10 blocks, you'd have a heart rate would end up being 150. If it was 20 blocks, for example, you're going to find out that the heart rate would be 75. And you'll see that this stuff kind of lines itself up here a bit. So 1500 divided by 20 comes out to 75. So ultimately, I just determine how many small blocks are there between there, and you can get some really accurate heart rates. You'll get them within a couple of beats per minute of one another, and that becomes quite accurate to read. So that's a great way to do this. Now, the computer compensates if the heart rate is irregular, meaning if the beats are not equally spaced between all of those. While it's far from perfect, you can kind of look here and see the numbers 300, 150, 100, 75, 60, 50, 43 are written about the same size. That 150 got a little big, but generally speaking, these are about the same distance apart. If I had lines that I was drawing through here, and they were something like this, and I was going up and down, and this was my heart rate, then the distance from here to here would be really short, so I think I'd have a fast heart rate. And the distance from, well, here to here would be very long. So there's another method that's used sometimes called the triplicate method. The triplicate method just means that we do the same thing, but we triple everything. So we take 900 divided by the number of large blocks between 3 beats. So I start at 1 beat, then I count out to the next beat, and the next beat. So when I get from, I start at the first beat, and second, third, I skip 2, and then to that third beat that follows. So in other words, it's really the 4th beat on there. I can get a better approximation off of there because that accounts for some of that irregularity. Even that's not that perfect. And the nice thing is that 6-second rule that I taught you in the last video works for all of this stuff. It doesn't matter so much if it's regular or irregular because over 6 seconds we've got a pretty good sampling, and the odds are that that's going to hopefully remain relatively consistent throughout. But these are 2 ways that you can determine an approximate heart rate. 300 divided by the number of large blocks would get you an approximate heart rate, or 1500 divided by the number of small blocks will equally get you that heart rate. If you have questions, next week in class would be the perfect chance to ask questions, and you'll get a chance to practice some of these rhythms. Send me an email if you have questions as well. Thanks.